What is up, everybody? Welcome back to the stream. Again, Tom McGurl here. We're doing some Rust tonight. We're going back to the book. If you've been following along, we finished the Rustlings exercises last week. It was awesome. A lot of fun with it. Today we'll be getting back into it with the book. If you're watching on YouTube, thank you for watching. Appreciate it. If you're watching on Twitch, thank you for being here. Appreciate it. We got Patatas in the chat, a regular in the chat, always helping out with some useful hints. So happy to have you here. So we're going to continue with the book today. We're on chapter 11. As always, got to plug it. If you've missed any of the previous chapters, don't worry at all. It's all up here on YouTube. Look, we got a pretty solid collection now. We've been doing this for a while, right? Every Tuesday, every week, 9 p.m. to 11 p.m., Twitch TV/Tom McGurl. Just my name up there. We got a Twitter URL. And the videos get posted on the following Wednesday. So look, we've got a pretty good collection building. I'm pretty excited about it. So we've got all of the Rust chapters of the book that we've gone through so far. So that's chapters 1 through 10, as well as the last few videos where we actually went through the Rustlings exercises. The Rustlings exercises were a great way for us to kind of flex some of those muscles of things that we learned in the book. We came across some things that we hadn't yet learned, but we kind of tackled through them. I think the only one we didn't do was one on threads, which was a pretty confusing one, but hopefully after we get through threads in the book, we can go back and try to solve that. But check them out here on YouTube. Subscribe if you want to get notifications on when the latest videos are up. And thank you if you've already subscribed and are already watching on YouTube. I really appreciate it. Also, if you want to follow the channel on Twitch, you'll get notifications for when I go live. You can always follow me on Twitter as well. I post whenever I go live there, as well as some other content. And expect some other more one-off content here to go up on the YouTube channel. Right now we have our book and the Rustlings, but I also have a video on Rust development with Docker, so how to set up a Docker container for Rust. And we have some other videos. We got one on building a live coding a serverless API with AWS Lambda, DynamoDB, and that's written in Node and TypeScript, and we use a little bit of S3 for image storage. Before that, we messed around with the React Native app, so that was a 7-part series, another long one, where we built a React Native app using Recoil.js. I wanted to try that out and figured build a craft beer cataloging app and try that out, so that was fun. Check it out. Some of the early ones, we were still trying to figure out the stream, so they might be lower quality, so I apologize in advance for that. But now we've kind of got things figured out, and we're cruising along. So happy to be continuing this, and thank you for watching. So let's jump in a bit. Really quick, though, everything we're going to do today, including all the code up to this point, are posted on my GitHub here. I'm still not using dark mode. I know. I don't know. I'm not a huge fan of the dark mode yet. Not quite. I don't feel like it's quite there yet. It's a little too dark, not enough contrast for me. So I'm sticking with the light theme, but check that out. So as always, if you've been watching the stream or following on YouTube, before we begin, we always have to give a shout out and a thank you to Steve Klobnik and Carol Nichols and anyone who contributed to the book from the Rust community. We couldn't be here doing this book or going through it without the contributions of Steve Klobnik, Carol Nichols, in the community. Without them, we wouldn't have a book, and we wouldn't be able to learn Rust in this amazing way. Wouldn't even be able to do the stream. So been going through the chapters, chapter by chapter, really enjoying it so far, really enjoying the pacing, and it's just been a lot of fun. So got to give them a shout out. And if you're on Twitter, give them a follow. Steve Klobnik and Carol Nichols, you can find them on Twitter. Awesome people in the Rust community, doing a great job. Clam Watson in the chat coming out with "Let's go, big ups, Carol." Absolutely. I also recently watched a talk that Carol gave on Rustlang. Highly recommend it. She's a phenomenal speaker. You can find that on YouTube. Just Google Carol Nichols. She's got some great talks on Rust. Very inspiring and really cool to see, some of the benefits of Rust and how people are using Rust. So definitely check that out. All right. Tonight is all about automated tests, right? We're going to learn about writing tests. We've seen tests. We've come across them in our day-to-day. Rustlings, right? Rustlings, we were just thrown in to tests. We had a test watcher running. We were able to read the tests and kind of decipher what we need to do based on the tests. Super cool. But today we're actually going to learn how to write them on our own. We haven't really done much of this, right? We've only done exercises where they were pre-written for us, and today we're actually going to learn how to write them ourselves. If you've never written tests, Now's a good time to do it, right? Tests are very important. We've been avoiding writing them, exactly. And if you haven't written them and you don't write them day to day, it's definitely a skill that takes a little practice. Everyone says you got to always test. But anyone that's tried to write automated tests or test in any language know that it's a little bit of a hurdle, right? It's not something you maybe get to right away, and it's not the first thing you learn. However, once you do learn it, there are a lot of benefits. And if you can get to a point where you're doing at least some test-driven development. I'm not the type of person who believes that it's possible to do test-driven development all the time. And those of you who aren't familiar with test-driven development, that's the practice of writing your tests prior to writing your code, writing the code to get the test to pass, and then refactoring the code, leaning on those tests to make sure you don't mess anything up and create regressions. It's a great practice. It is very difficult in practice. And we kind of saw that with Rustlings. We had a little TDD going, and we did some test-driven development when we were doing some of our Rustlings where we'd write the code, get the test to pass, then refactor the code. It's very powerful once you can get there. So let's learn about automated tests. All right? All right, writing automated tests. In his 1972 essay, The Humble Programmer, Edgar W. Dijkstra said, "Program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence." I love that. Look at that. Let's read that again. That's powerful, right? And if any of you are familiar with Dijkstra, you may know that name. It may sound familiar. You may know Dijkstra's algorithm, a very popular algorithm from a very popular programmer. So let's read that again. Program testing can be a very effective way to show the presence of bugs, but it's hopelessly inadequate for showing their absence. So it can show you when there's bugs, but it can't show you their absence, right? So you need to have these things. That doesn't mean we shouldn't try to test as much as we can. I love it. All right. Correctness in our programs is the extent to which our code does what we intended to do, right? So that's correct. If it does what we intended to do, it's correct. Rust is designed with a high degree of concern about the correctness of programs. We've seen that. Type safety, right? Option type, result type. We want our things to be correct. But correctness is complex and not easy to prove. Rust's type system shoulders a huge part of its burden, but the type system cannot catch every kind of incorrectness. As such, Rust includes support for writing automated software tests within the language. As an example, say we write a function called add2 that adds 2 to whatever number is passed to it. This function's signature accepts an integer as a parameter and returns an integer as a result, that integer plus 2. When we implement and compile that function, Rust does all the type checking and borrow checking that you've learned so far to ensure that, for instance, we aren't passing a string or something invalid, right? We're actually passing an integer. But Rust can't check that this function will do precisely what we intend, right? Which is to return the parameter plus 2. The parameter plus 10 or the parameter minus 50, that's where tests come in, right? So it knows that we're passing it the right thing, we're giving the right return type, but it doesn't know what the logic, or some people will call it the business logic of the function, what the function is actually intended to do. And sometimes only us as the programmer know the intention. And if you've been coding professionally or learning to code, tests are a great way to do this. And there's other good things that you can do to show the intention of what you're trying to do. One of my favorite things is to leave a comment in the code that says what the intention of the code is. Even though you could probably decipher it by reading the lines of code, putting a comment in there leaves information for the reader of the code and gives them a foreword to what you're doing within your code. So always good to include a comment. And that's just kind of a side. Also, a great practice that I've been doing with comments and testing is if you're reading someone else's code and you have a question, when you get the answer to that question, put the comment back in the code for future people reading that code. Or if you're reviewing someone's pull request and you're looking at their code and you have a question and you ask it in the pull request and they respond with an answer, ask them to put that in a comment in the code because it's a good cue, right? If there's something confusing, put that comment in the code. And Clam Watson in the chat mentioned, or leave the comment for yourself in 6 months, right? We sometimes come back to code. We often come back to code that we've written ourselves. And having that comment there is just a nice tip to say, hey, this is what this code's intended to do. Here's why. Just a great practice. So one of the other things just to mention that we can do along with tests to help kind of declare what our intention is, right? We can write tests that assert, for example, that when we pass 3 to the, oh, let me move this over here so you can see it. Move out of your way. I'm in the way. We can write tests that assert, for example, that when we pass 3 to the add2 function, the return value is 5. We can run these tests whenever we make changes to our code and make sure any existing correct behavior has not changed. That gives us the ability to refactor, clean up our code, and make sure things still work. Testing is a complex skill. Although we can't cover every detail about how to write good tests in one chapter, we'll discuss the mechanics of Rust's testing facilities. We'll talk about the annotations and the macros available to you when you're writing tests, the default behavior, as well as the options provided for running your tests, and how to organize tests into unit tests and integration tests. All right, I'm interested. I want to hear about it. All right, oh, let me go forward here. Let me hide this. We don't need this right now. Okay, how to write tests. I'm just gonna move back over here. How to write tests. Tests are Rust functions that verify that the non-test code is functioning in the expected manner. The bodies of test functions typically perform these 3 actions. 1, set up any needed data or state. 2, run the code you want to test. And 3, assert the results are what you expect. So again, 1 is set up any needed data or state. Sometimes your function will require some input, right? So you can set up some needed test data. Sometimes you need to mock things. 2 is run the code, right? You have to run the actual code you want to test. You have to call the function or whatever. And 3 is that assert the result of your call or your function call are what you expect. Let's look at the features Rust provides specifically for writing tests that take these actions, which include the test attribute, a few macros, and the should panic attribute, which we've seen. If you followed along in the rustling videos, we saw the should panic. It's basically an assertion that your code panics on a certain test case, right? Okay. The anatomy of a test function. At its simplest, a test in Rust is a function that's annotated with the test attribute. Attributes are metadata about pieces of Rust code. One example is the derive attribute we used in structs in chapter 5. So you remember we wanted to be able to print out our structs. And so for that, we used the derive debug, which allowed us to print our structures in a very nice way. So that was one example of an attribute. To change a function into a test function, add the hashtag or bang test on the line before the function. When you run your test with the cargo test command, Rust builds a test runner binary that runs the functions annotated with the test attribute and reports on whether each test function passes or fails. Pretty cool. So we're going to use cargo test to run these. When we make a library project with cargo, a test module with the test function in a test module with a test function in it is automatically generated for us. Weird. I think there's a typo there. The module helps you start writing your tests so you don't have to look up the exact structure and syntax of test functions every time you start a new project, right? So that's pretty cool. You can add as many additional test functions and as many test modules as you want. Awesome. We'll explore some aspects of how tests work by experimenting with a template test generated for us without actually testing the code. So we'll experiment with the template generated. Then we'll write some real world test cases that call some code that we've written and assert that its behavior is correct. I'm all for it. All right, here we go. We're going to dive in a little bit. Let's create a new library called adder. And if you remember, we've been using cargo new, right? That generates a new project. And you can give it this -- lib parameter, which is going to say that the code generated is going to be a library binary. And instead of having a main RS, you're going to end up with a lib RS. So let's go ahead and do that. So what I'm going to do is move this over here, move this over here. And so this is where we've been doing the Learn Rust live stuff. So I'm going to go ahead and get out of your way really quick so I can run this command. And so first I'm going to go into my projects directory. That's where we've been putting everything. I'm going to make a new directory. How have we been calling these things? Let's see. I think we've been using the chapter name. Yeah. Okay. So chapter name. So we're going to do make dir chapter 10 automated tests. We'll go into there. And here we're going to do cargo new adder. We're going to specify that it's a lib. And then we're going to jump into that adder project. All right. Let's open that up over here. Chapter 11. All right. There we go. There's our test, and it's making an assertion. All right, so let me switch back over here. Okay, so here's what we have. The contents of source lib file in your editor should look like listing 1.1, and they do, so we're good. For now, let's ignore the top 2 lines and focus on the function to see how it works. Note the test annotation before the function, so that's this here. This is the annotation with the attribute, right? This attribute indicates this is a test function, so the test runner knows to treat this function as a test. We could also have a non-test functions in the test module to help us set up common scenarios and perform common operations. So we need to indicate which functions are tests by using the #test attribute. The function body uses the assert equal macro to assert that 2 + 2 is equal to 4. The assertion serves an example of the format for a typical test. Let's run to see if the test passes. So let's run cargo test to see what happens. So let's do that. Cargo, get out of here. Cargo test. Awesome. So you can see here, we got our test passing. Everything looks good. Cargo test. Test it works. Okay, obviously it works. This is a very basic assertion, but cool nonetheless. Cargo test is definitely working in our favor. Cargo compiled and ran the test. After the compiling finished and running lines is the line running one test, the next line shows the name of the generated test function called it works and the result of running that test, which is okay. Overall summary of running the test appears next. The text, which reads test results okay, means that all the tests pass, and the portion that reads 1 pass, 0 failed is the total number of passed tests and failed tests. So if you've done testing in other languages like JavaScript with Jest or Mocha, or you've done something in Python with PyTest or unit test, you'd have some similar output. So that might be familiar. Because we don't have any tests we've marked as ignored, the summary shows 0 ignored. You can ignore tests, so you might be working on some code and you know the test is failing, so you want to ignore it. Or, for example, maybe you want to rewrite that test and restructure that test, so you ignore it for now. Or you're changing that code significantly and you want to just ignore it until you're done changing it, then you turn it back on. Because we don't have any tests that we've marked as ignored, the summary shows 0 ignored. We've also filtered out the test being run, so the end of the summary shows 0 filtered out. So we haven't filtered out any tests. You can filter some out, we haven't done that. We'll talk about ignoring and filtering a test in the next section, okay? The 0 measured statistic is for benchmark tests that measure performance. Benchmark tests are, as of this writing, only available in nightly rest. So whenever this is published, they're only available in nightly rest, which we're not using. However, if we update, they might be available. Pretty cool. Might have to check out the nightly rest. Could be cool. See the documentation about benchmark tests to learn more. All right. The next part of the test output, which starts with doc tests adder, which is this part here in the output. Let me pull that up. You can see it here. Is the results of any documentation tests. We don't have any documentation tests yet, but Rust can compile any code examples that appear in our API documentation. That's pretty cool. This feature helps us keep our docs and our code in sync. We'll discuss how to write documentation tests in documentation comments as test section of chapter 14. Now we'll ignore the doc test output. So that's pretty cool. You can actually test the code in your docs. That's powerful because if you're changing that code, it makes sure it works, right? So sometimes I've come across documentation where the example doesn't work anymore or it's outdated. So that's a pretty cool tool to have in our toolbox for making sure that works. I like that. Okay, so let's change the name of our test to see how that changes the test output. Change the it works function to a different name such as exploration. All right, we'll do it. Save that, and let's test that out. Here it says test, exploration, okay. So just change the name as expected. Nothing too unexpected there. Interesting. The output now shows exploration instead of it works. All right, let's add another test, but this time we'll make a test that fails. Tests fail when something in the test function panics. Each test is run in a new thread. And when the main thread sees that a test thread has died, the test is marked as failed. Of course, we know, if you've been following along Rustlings, we know there's a should panic assertion where we can actually leverage the fact that it panics as an assertion. So we'll see that in a second. We talked about the simplest way to cause a panic in chapter 9, which is just to call panic, call the macro. Enter the new test, another. So your lib file looks like the below. So let's do that. So let's go ahead and add our hashtag test so they know it's a test function. And let's do another. And we're just going to panic right away. We're going to call that panic macro. Make this test fail. All right, now let's go ahead and run cargo test. I'll make this a little bit bigger so we can all see it here. All right, so here we have running 2 tests. It shows that the another test failed. It shows that the exploration test still passed. And here we can see the failures broken out, right? So we can see failures, test another, standard out. Thread, test another, panicked at, make this test fail. So there's our message. It shows you where it happened. Line 10, column 9, line 10, column 9. So that's pretty cool. And then it's you have a summary of your failures here. Failures, test another, test results failed, 1 passed, 1 failed, 0 ignored, 0 measured, 0 filtered out. So pretty cool to see that output change. All right, so here we're talking about the output. This is what we just covered. It panicked. The next section lists just the names of all the failing tests, which is useful when there are lots of tests and lots of detailed failing test output. We can use the name of failing test to run just that test to more easily debug, right? So we could say, okay, this test failed, rerun it. Grayjack in the chat. What is up, Grayjack? Thank you for stopping by. Happy to have you here. All right. The summary line displays at the end, overall, our test result has failed. We had 1 test pass and 1 test failed. Now that you've seen what test results look like in different scenarios, let's look at some macros other than panic that are useful in tests. All right. So some other macros. We're going to use the assert macro. We've seen this. Yo, low key, like, we're kind of almost rustaceans. We've seen a lot of stuff. We're like, the book's telling us stuff, and we're like, oh, yeah, I've seen that. I've seen it. Yeah, I've seen that. No big deal. We're like tiny we're like the kind of like sand crabs, rustaceans. We're not like quite like full crab, full shell. We're like soft shell crabs. All right, we're soft shell rustaceans. That's what we are. Just for now, we're gonna be hard shell blue claws in no time. All right, checking results with the assert macro. The assert macro, provided by the standard library, is useful when you want to ensure that some condition in a test evaluates to true. We give the assert macro an argument. This is kind of a version of it, right? But this is equal. So we give it an argument that evaluates to a Boolean, true or false. If the value is true, assert does nothing and the test passes. If the value is false, assert macro calls the panic macro, which in turn causes the test to fail. Using the assert macro helps us check that our code is functioning in a way we intend. Makes sense. In chapter 5, we used a rectangle struct and a can hold method, which are repeated here in listing 11.5. Let's put this code in our lib file and write some tests for it using the assert macro. All right, so let's put this code in here. So what we'll do is we will say, let's put this over here, struct rectangle. Rectangle is going to have a width. It's going to be an unsigned 32-bit integer. It's going to have a height. It's going to be an unsigned 32-bit integer. That's our struct. And then we're going to have, we want to derive debug so that we can print out stuff around it. And here's another attribute, right? Derive. And this is the one we've seen before. All right. And then we need an implementation function for rectangle. And that's just going to be can hold. And it's whether or not it can hold another rectangle. So whether or not one rectangle could be encompassed in the area of another rectangle. So we're gonna write our function can hold. I'm just gonna type it out to get a little practice. So self, again, self is passed to all of the implementation blocks. Other, which is the other rectangle we're testing, and it is a reference. Here we're going to say a reference to a rectangle struct. And it's going to return a Boolean true false for whether or not the other rectangle can be contained within the area of our rectangle instance. Okay, so we're going to do self.width is greater than other.width, and this is just the formula, right? And the height has to be greater, right? So self.height greater than other.height. All right, so there we have our canHold function. The canHold function method returns a Boolean, which is perfect use case for the assert macro. In listing 11.6, we write a test that exercises the canHold method by creating a rectangle instance that has a width of 8, a height of 7, and asserts that it can hold another rectangle that has a width of 5 and a height of 1, which it absolutely should be able to contain, right? So let's write those tests. So here we have tests, and so this is a little bit different. We can see here right away we have our module test. It's calling use super, which I'm sure they'll break down. Yeah, they'll break down out here. So let's type it up and then we can see what this does for us. Use super, and we're using all of the functionality of super. That's why we have this. All right, so we need our new test. Again, we're going to mark it with test, and it's going to be called function larger can hold smaller, which it actually should be able to do, right? That's the whole point. And we're going to create a larger rectangle, create an instance of a rectangle struct. We give it a width of 8, which is an unsigned 32-bit integer, a height of 7, and now we'll create the smaller rectangle, width of 5, height of 1. And now here's where our assertion comes into play. Remember, we set it up, call the function, and assert that it behaves correctly. So right now we're going to call the function within our assert. And again, assert is looking for a Boolean, which is perfect because our function here returns a Boolean. If it returns true, our test pass. If it returns false, it causes a panic, which in turn causes our test to fail. And that's how the assert macro works. So we're going to do larger, canHold, and then you can see other here. It's looking for other. It's looking for a reference to a rectangle. So we're going to give it a reference to smaller. Save it, and let's read the description of what we actually did here. So note that we've added a new line inside the test module, the one that we called out. Use super : star. The test module is a regular module that follows the follows the usual visibility rules we covered in chapter 7 in the pass for referring to an item in a module tree. Because the test module is an inner module, we need to bring the code under test in the outer module into scope of the inner module. What does that mean? Let's go over it. Gray Jack in the chat real quick. It's been a while since I saw your stream. No worries, since Halloween. We had a fun Halloween stream. It's been great. Thank you for asking. The progress has been good. We did the rustlings. Exercise has been fantastic. Check them out on YouTube if you're interested. If not, skip them and follow along here. But yeah, glad to have you back. And thank you for stopping by. I appreciate it. All right, so we need to pull in the outer scope, right? So we're in a module here called test. And so our function that is under test is out of the scope, right? And so here, that's what we're talking about. Because the test module is in an inner module, we need to bring the code under test, which in our case is the canHold function, in the outer module into the scope of the inner module. We use a glob here so that anything we define in our outer module is available to this test module. So super just refers to the outer module, and star refers to anything defined out here, right? It's saying here the associated function is not used, and that's because it's not used in the outer module. However, it is used in our inner test module. Gray Jack, saw that you adopted Rust Analyzer. Do you like it? I love it. Thank you for that shout out. I absolutely have been loving it. It works well when you have cargo set up, and yeah, it's been really good. So thank you for that tip. Gray Jack also created a cool theme that we used for a little while, which we should try again now that we have Rust Analyzer set up. All right, so let's run cargo test. Let me get out of your way. Switch it up. I'm going to go top left. What's he doing up there? Cargo test. All right. Associated function is never used. That's fine. Even if we use it in a test, it's still not used by our code. So what this is telling us is, hey, you've never used it. You've tested it, which is great. It works, whatever. But you haven't used it, so you don't really even need the test because you're never actually using it. You don't even need the code. And we can mark it with this, right? Okay, so what does it do here? Expiration, okay, another, failed, which we expect. We didn't modify another, it's still gonna fail. Larger can hold smaller, which is not what we actually wanted to call it. We wanted to call it larger can hold smaller. A little bit of a typo. So what I'm gonna do is I'm gonna clear that out and run the test. There we go. Larger can hold smaller. Okay, so it worked. Awesome. So our assert worked, right? So pretty cool. All right. The expression is supposed to return true, so our test should pass. And it does. It does pass. Let's add another test, this time asserting that a smaller rectangle cannot hold a larger rectangle. Yo, I'm all for it. Let's try it out. Let's try it out. So let's do another test. Smaller cannot hold larger. Yeah, I've seen some small stuff hold big stuff. I've seen it. Maybe not rectangles, but don't underestimate little crabs. They're pretty strong. They could hold big stuff, but not rectangles, right? We're talking about rectangles, people. Come on, chill. Patatas. You can't have bugs if you don't have code. Yo, that's like the GIF. We need that GIF that's like, right? You can't have bugs. This is true. This is true. All right, so let's try it out. So let's create the larger. I think we can just basically, we're just using the same stuff here. We're just asserting something different, right? So we're gonna use the same setup. We're just gonna assert something different. And so what we're gonna assert is assert, and here's the key thing. We're negating this expression, right? So we're saying not smaller can hold larger. This is key. What's going on here? Oh, reference. Look, this is key. We had this negation. So we're saying assert that it can't. Not smaller can hold larger, right? And this should pass. And you can see here, because the correct result of can hold function in this case is false, we need to negate the result before we pass to assert. Otherwise, it would panic. So let's go ahead and run this and just see what happens. Bam, we're good. Oh wait, we're not good. We're not good. Why are we not good? Because I forgot to mark it with test. And let's see what this is telling us. Function is never used. So what we want to do is we have to mark it with test. So that was a cool little experiment to see what that does. There we go. Larger can hold smaller. Smaller cannot hold larger. Pretty great test, right? And we have another still failing on purpose and expiration passing. So pretty cool, pretty cool. Very easy. I like that you can just write the test right along here. And the cool thing, I didn't pull anything in, right? I didn't pull in any libraries. I didn't need to go, come on, if you've used JavaScript, you know we've searched like, what do I use, Jest or Mocha? Enzyme. Enzyme's not cool anymore, dude. We're using Jest now. I remember when Jest wasn't cool. Mocha. Are you gonna use Jasmine? Are you using Chai? We're just using what's built in here. That's the beauty, right? Even Python, right? You're like PyTest, unit test. PyTest is the right choice, but you know, whatever. You see there's options and we just have these here. Patata says, I like themes that don't hurt my eyes. I'm hoping Monokai Ocean's not hurting your eyes. Having sensitivity light is annoying. Yes. I tend to, this is a side tip, I like to have a good set of light themes and a good set of dark themes. If I'm working outdoors, I switch over to that light theme. If I'm working inside, I got the Monokai on 100%. I would like it. It'd be cool. And maybe this is a feature I don't know about. If VS Code could use your operating system, if you have your operating system on auto, dark, or light, to dictate, and you can pick, hey, this is my light theme, this is my dark theme. Maybe you can do that. Maybe it's something that we should code. Who knows? All right, so Here we have our tests. The 2 tests pass. Now let's see what happens to our test results when we introduce a bug in our code. Let's change the implementation of can hold method by replacing the greater than sign with a less than sign when it compares the widths. So just the widths. Let's just do the widths. So here I'm going to change this to a less than sign, and we're going to run cargo test. Check it out. Test fails right away. Look at this. Which one fails? Smaller or larger can hold smaller. Tells us right away, right? It's what we expect. If you've used tests before, this is what you expect, but very cool. It makes sure that we're not going to break our code, right? So if someone accidentally switched those, or you accidentally switch them, or you're trying to test something, that's what the tests are there for. They're for you to lean on and to get protected a little bit to make sure that you don't break stuff. So pretty cool. All right. Our test caught the bug. Very cool. Pretty cool. Arby's is pretty cool. All right. Test equality with the assert equal and assert not equal, which is what that stands for. Macros. We've used these. We have it, right? It's right here. Yo, where is it? We have it, right? Common way to test functionality is to compare the result of the code under test to the value you expect the code to return to make sure they're equal, right? You could do this using the assert macro and passing an expression like the equal operator, which is what we use to because it will return a Boolean. However, there's a common test that the standard library provides, a pair of macros, assert equal and assert not equal. And what we can do is instead of doing the comparison, we just give it 2 values as the arguments. And we either assert they're equal or we assert they're not equal. So these macros compare 2 arguments for equality and inequality respectively. They'll also print the 2 values in the assertion fails, which is very nice. If you've ever had an assertion fail, it's very nice to see this does not equal this. And then you say, oh, -5 doesn't equal 5. Well, it shouldn't be negative. Something's wrong in my code. So that's very, very, very useful. Which, yeah, makes it easier to test why it failed. The assert macro only indicates that it got false value for the expression, not the values that lead to the false. So when we're comparing 2 values, we should always reach for assert equal or assert not equal over assert because we'll get that extra information, which is always useful. We're going to write a function named add2 that adds 2 to its parameter and returns a result. Then we test this function using the assert equal macro. So we're going to go ahead and create a public function out here. Again, it has to be public because we want to be able to access it. These are accessible because of the struct, but here we need a public function. So we'll say function add2, and what are we going to do? We're going to take an signed 32-bit integer, any signed 32-bit integer. We're going to return a signed 32-bit integer, and what are we going to do? We're just going to add 2 to that integer and return it with the implicit return. Okay. Now we're going to add a function that tests this. So I'll just add it. I'll add it up here as the first one. So let's just do, again, we're going to start out with our test. And notice it added this little thing for us here. Who knows what this does? What do you think this does? It's going to run our test. But I could not find the cargo toml. I bet we can get this to work, but pretty cool that that's an option. I like that. So kind of cool. Maybe we'll get that to work later. All right, so let's start out with function. It adds 2, right? And we're going to go ahead and assert equal, where it's a macro. And we're going to assert that 4 equals add 2. And we're going to pass it 2. Ooh. In the chat, Patata says, now add to I32 max. Ooh, interesting. We could try that. Let's see if this one works. So here we're just going to assert this, and we got to close it out with a, there we go. Okay, so let's go ahead and run this. So we're just going to run cargo test. Let's change this thing back. Right? And there we go. So we have our it adds to running correctly. So that's assert equals. Pretty cool. So here we see that the first argument we gave the assert equal macro is 4 is equal to the result of calling add 2 to the number 2. 2 plus 2 is 4, right? The line for this test is test, it adds 2, okay, and the okay text. So we saw that printed out here, right? It takes 2 to make a thing go right. You know? Let's introduce a bug in our code to see what it looks like when a test that uses assert equals fails. We're going to see that output, right? So let's let's change it like they're doing. Let's change this to 3, right? So now it should fail. And let's try it out. Let's try it out. It failed. It failed good. Look at that. It adds to failure. And why did it fail? Check it out. This is what's cool. This is why we use assert equal instead of assert in this case. Panicked at assertion failed. Left does not equal right. Left is 4. Right is 5. And this is the sides of the assertion. So left in this case, if we go to our assertion here, move this down a little bit so you can all see it. Left is 4. Right is 5. So it's telling you that whatever you put on the right is returning 5. So that's an indicator for us to say, hey, our code's messed up. Got to fix it, right? So what we're going to do is we're going to fix it back. So let's go here and we're going to assert that it says the right thing. So we see this and we say, oh, it should be 2, not 5, because the function's called add 2, not add 3. Our test caught the bug. The it adds 2 test failed, and it displays the left and the right, which is awesome, right? Note that in some languages and test frameworks, the parameters of the function that assert 2 values are equal are called expected and actual. And the order in which we specify the arguments matters. However, in Rust, they're called left and right, and the order in which we specify the value doesn't matter. So we just know, look at the left argument, look at the right argument. So that's pretty nice, because it can be confusing. Sometimes you're like, which one is the one that is my code, and which one is the one that is being run? So pretty cool that they're just like left and right, you know, very straightforward. Very straightforward. We could write it, the assertion in this test as assert equal, add 2, 2, 4, which would result in a failure that displays the opposite, right? So pretty cool. The assert not equal macro will pass if the 2 values we give it are not equal, and fail if they end up being equal, right? The macro is useful for cases when we're not sure what the value will be, but we know what the value definitely shouldn't be or won't be if our code is functioning as we intend. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends on the day of the week that we run the test, maybe some other side effects, the best thing to assert would be that the output of the function isn't equal to the input, right? That it should do something. So that's a good assertion. Under the service, the assert equal and assert not equal macros use the operator minus, or sorry, I think that's, sorry, it's not showing up here. Equal, equal, and does not equal, respectively. So they're doing those comparisons for you under the hood. When the assertion fails, these macros print their arguments using debug formatting. So that's key. They're not using display formatting. They're using debug formatting. So you can actually have a struct there, which is nice. When the assertion fails, they print it out using debug formatting, which means the values being compared must implement the partial equality and debug traits. So if you are asserting things, because it's using equal, equal, and does not equal, it needs to implement the partial equality trait. And since it's printing it using debug, it must also implement the debug trait, right? All the primitive types and most of the standard library types implement these traits. For structs and enums that you define, you'll need to implement the partial equality to assert that values of those types are equal or not equal, and you'll need to implement debug to print the values with the assertion fails. We've done that here, although we're not printing the values right now. So good to know. Partial equal, right? If we're gonna, because it's gonna be comparing, and debug if we want to print it out and see a nicely printed thing for the left and right. Okay. Because both traits are derivable traits, as mentioned in listing 5.2 in chapter 5, this usually is as straightforward as adding the hashtag, which we've done here, right? Let's try this. This isn't here. Let's try comparing 2 rectangles to see if they're equal. And then what we can do is we'll have to add that trait, right? We'll have to add that partial equality. Or in this case, we could just see how the debug works. So for example, let's do this. Let's say, let's create a function called new. And new is going to just simply return a rectangle, and it's going to be a default rectangle. And so what we'll do is we'll return rectangle with a width of 1 and a height of 1. Okay, so we have this function new, just returns a rectangle. And so we're going to go ahead and assert. We're going to do our test. Oh. And then we're going to say function default rectangle with height of 1. Long name, but you get the point. And so what we're going to do is we're going to assert equal rectangle or let's do this. Let's do rectangle new dot height 1. Let's see what this is. Function takes 1 argument. Oh, self. So we can do, get rid of that. All right, let's try running our tests. Oh, sorry, were you not able to see that? Was I in the way? Let me show what I did here. So I just created a function rectangle new, which returns a new rectangle, a default rectangle, and I'm just asserting that the height is 1. But I'm going to actually change this. I'm going to assert the height is 4 so that it fails. Cool. Failed. Let's see why. GreatDeck said, I think it would be better to implement default, but I'm not sure you already saw that trait. Yes, that's true. So let's see what we have here. So default rectangle, thread, panicked at, assertion failed, left equals right. Left is 1, right is 4. So pretty cool. So that's pretty cool. We can get rid of that now. We can just assert that it equals 1 and run our test, and we're all good. And it's comparing primitives, so we're still good. We could try to compare rectangles, right? We just had to make sure we implement partial equality. Adding custom failure messages. Okay. You can also add a custom message to be printed with the failure method as optional arguments to assert, assert equal, and assert not equal macros. Any argument specified after the one required argument to assert, or 2 required arguments to assert equal. So add a third argument. That's pretty cool. They're passed to the format macro, discussed in chapter 8, which we saw. So you can pass a format string that contains curly bracket placeholders and values to go in those placeholders. Custom messages are useful to document what an assertion means when a test fails. You'll have a better idea of what the problem is with the code. So that's kind of cool. So you can actually put, hey, what does it mean? What does it actually mean if it fails? Why did it fail, right? What is not equal to what? For example, let's say we have a function that greets people by name, and we want to test that the name we pass into the function appears in the output. Okay, let's add it. So we'll just do it right here in our same function. Let me just scroll down a little bit. So what we'll do is we'll create this function. It's called greeting. It takes a name that is a string slice and returns a regular string, format, hello, and the name. Okay, pretty cool. And let's write a test for that. So we'll do it right here, test, greeting contains name. Let results. And so here what we're doing is we're just calling our function and getting a result instead of calling the function in our assertion. It's just to say that, hey, this is the result we expect. And it's also because we're going to check that the result contains Carol. And so we could call the function, but it'd be like kind of, chaining function. So in this case, it's just a little nicer way to make the code readable. So greeting Carol, the author, right? Carol Nichols, Easter egg. No, maybe not really, but pretty cool. Excuse me. Okay. So we're going to call the function, and then we're going to do assert result.contains Carol. Pretty cool. The requirements for this program haven't been agreed upon yet, and we're pretty sure that the hello text at the beginning of the greeting will change. We decided we don't want to have to update the text test when the requirements change. So instead of checking the exact equality, right? So instead of checking that it prints out hello Carol, we just care that it contains this thing, right? Instead of checking the exact equality of the value returned from greeting, we'll assert that the output contains the text of the input parameter, just in case we change the greeting from hello Carol to bonjour Carol, or bonsoir, or maybe hola, right? Maybe we change languages. Maybe we're multilingual, right? Who knows? Maybe it's internationalization. Let's introduce a bug into this code by changing greeting to not include the name and see what this failure looks like. Okay, we're gonna just change this. We're gonna go ahead and not include the name. We're just gonna say hello Twitch. Hello Twitch. Okay, let's go ahead and run it. Let's see what we got. What do we got? Failed. And what does it say? Greeting contains name. Panicked at assertion failed. Result contains Carol. So no real good information. It's just like, it failed. Result contains Carol failed. It panicked. It didn't contain it, right? Okay. The result indicates that the assertion failed and which line into the assertion it failed on. A more useful failure message in this case would print the value we got from the greeting function. Let's change the test function, giving it a custom failure message made from a format string with a placeholder filled in with the actual value we got from the greeting function. Okay, let's try it. So let's change this. So we have let result greeting Carol. We're changing our assert a bit. Here's our first argument, and we're going to throw a second argument on here, and that's going to be the message. Greeting did not contain name. Value was, and what are we going to do? We're going to give it, again, it's calling format for us, so we're going to give it results. So pretty cool. Let's go ahead and run it. Wow, look, this is much more informative, right? It says here, the greeting did not contain the name. The value was hello Twitch. So look at that, more informative and very little extra work. I like it. I like it. All right, next up, checking for panics with should panic. We've seen this in rustlings. We've seen checking for panics. It's pretty powerful. Hold on, I'm gonna move a little closer. We've seen this, but pretty awesome stuff. Let's dive in. In addition to checking that our code returns the correct values we expect, it's also important to check that the code handles error conditions as we expect. For example, consider the guess type we created in chapter 9, listing 910. I don't remember it. Our code that uses guess depends on the guarantee that guess instances will contain only values between 1 and 100. We didn't create that in chapter 9. Didn't we create that in chapter 2? Oh, I guess we created the initial guessing game, and then we went back, right? And we created that type after. Remember these things. We can write a test that ensures that attempting to create a guess instance with a value outside that range panics. So we can actually assert the panic. We do this by adding another attribute, should panic, to our test function. This attribute makes a test pass if the code inside the function panics. The test will fail if the code inside the function doesn't panic. So here we have an example. And I'm going to go ahead and I'm just going to go ahead and copy this. So, because we've written it before. So here we have our guess. We have our public function new. So it's available within our test here. So new is going to take a value, okay, just similar to what we did with our rectangle above, right? So new is going to take a value and it's going to return a guess. If the value is less than 1 or greater than 100, it's outside the range and therefore it's going to panic. so we can write a test that expects that it should panic. And that's pretty cool because we want to test all the cases, and a panic is a valid arm of our function or a valid branch of our function. So we should be testing as much of our function as possible. And if anyone's familiar with code coverage tools, while I'm not a giant fan of them because I don't think they are indicative of well-written tests by any means, or in that fact, I don't think they're indicative of code coverage. But this is a case where you do want to cover this line of code, right? We want to make sure that if we wrote this code, it has purpose, it has meaning, it should be under test. And so the should panic is going to let us test this arm of the function. And I like that. So let's go ahead and do it. Even if I didn't like it, we're going to do it, right? All right, so let's do it. So we got test, and what we're going to do is we're going to give it the should panic attribute. I'm about to panic, shit. All right, greater than 100. We're going to create a new guess. And again, we're not asserting anything here. That's key, right? We're not calling assert. We are just expecting it to panic. The assertion is kind of happening just here with this attribute. Because as soon as I call new, it's going to panic. And as soon as a panic happens, the test would fail. But because we've put this attribute, we're expecting it to do that. We're like, we expect, we understand that that's going to happen. And if that happens, we're all good, right? So let's run our tests and see what happens here. So let's go ahead and run that. Okay. Where is, I didn't save it. Classic Tom, come on, Tom. There we go. Default rectangle, still not it. Where is it? Greater than 100. Okay. So here we can see it's okay. It worked. We're all good. It panicked. So that's great. Looks good. Now let's introduce a bug in our code by removing the condition that the new function will panic if the value is greater than 100. All right, so we're going to mess with our function. We're going to remove this part of the condition. Ooh. And now we're going to rerun our code. Check it out. Check this out here. Greater than 100. Test did not panic as expected. Panicked at, that's a different one. But here it did not panic, right? So now we know it should have panicked. So pretty cool. That's a cool macro. Very useful. I like it. All right. There we go. It'll fail. We got that. We don't get a very helpful message in this case, but when we look at the test function, we see that's annotated with should panic. The failure we got means that the code in the test function did not cause panic. Tests that use should panic can be imprecise because they only indicate that the code has caused some panic. A should panic test would pass even if the test panics for a different reason. So let's say we had two arms of our function that panicked. This would work, right? So we're not actually asserting what the panic is in this case. It could be any panic that could make this test pass. A should panic test would pass even the test panics for a different reason, right? That's what they said. To make should panic test more precise, we can add an optional expected parameter to the should panic attribute. The test harness will make sure that the failure message contains the provided text. For example, consider the modified code for guess in listing 11.9, where the new function panics with different messages depending on whether the value is too small or too large. So that's awesome. So what we're going to do is we're just going to copy this over here into our guess. And now there's two versions. There's this one where if it's too small, it says guess value must be greater than or equal to 1. And if it's too large, it says it has to be less than 100. And now we can actually assert with this extra text, right, which one we're expecting. And so greater than 100, we just put here, it says here, should panic expected equals and what we expect it to be. Or what we expect it to contain in this case. It's not the full text. And I misspelled expected. And let's try it. Let me move myself. There we go. Okay. Whoa. What happened? Whoa. What is happening? There we go. I almost caused a transition on you. That wouldn't have been fun. Okay. There we go. It passed. Greater than 100. Because we got the correct panic. That's super cool. Awesome. Okay. So let's see. The test will pass because the value we put in the should panic attribute expected parameter is a substring of the message that the greeting new function panics with. We could have specified the entire panic message that we expect, which in this case would be guess must be blah, blah, got 200. What you choose to specify in the expected parameter for should panic depends on how much of the panic message is unique or dynamic, right? So how much of it differs from the other panics. And if we did want to do it, we'd have to, since the 200 is dynamic, right, we'd have to account for that. What you choose depends on how much is dynamic and how precise you want your test to be. In this case, a substring of the panic message is enough to ensure that the code in the test executes the else if value greater than 100 case. So that's all we need to know it made it to this, right? Because that's where it differs. If we just expected value must be, that wouldn't be enough, right? So pretty cool. To see what happens when a should panic test with an expected message fails, let's again introduce a bug in our code by swapping the bodies of the if value 1 and if value 100 blocks. So what are we going to do? We're going to swap out the bodies of this code here. So let me go ahead and do that. I'm just going to go ahead and paste those out here. All right. Oh, let's see what that ends up doing. All right, so it failed. It says here, panic did not contain expected string. Panic message. Guess value must be greater than or equal to 1. Got 200. Expected substring. And you can see they don't match. So pretty cool. I'm going to go ahead and put that back. Pretty cool. I think that's super useful, especially for, we want to panic in some cases. It's cool to be able to test all the arms of it. I like it. All right, moving on. The failure message indicates the test did indeed panic as we expected. Yep. Okay, using result type. So we learned about the result type. Now we're going to use that in a test. So far, we've written tests that panic when they fail. We can also write tests that use result, right, over type T and over type E. Here, the test from listing 11.1 rewritten to use result TE and return an error instead of panicking. Okay, so let's go to it works. Where is that? Oh, I think we got rid of it works, right? I think we tossed it. Let's see. It works. Yeah, nothing. All right, so let's rewrite it works. So let's go up here and rewrite it to use a result. So here we're going to say test. And I'm just going to put a comment. Test using results. T, comma, E. All right, so function it works. And it's going to return type result. In the OK case, it's going to return the unit type. In the error case, it's going to return a string. Okay, if 2 plus 2 equals 4, return OK and the unit type. Else, return an error. And again, the error is going to be of type string. 2 plus 2 does not equal 4. And we'll just .toString that. Okay, so it's not using an assertion. Instead, it's using the result type. So it's almost like a regular function in this case. The it works function now has a return type in the body of the function rather than calling assert equal macro. We return OK when the test passes and error with a string when the test fails. Writing tests so they return a result enables you to use the quotation mark operator in the body of tests, which can be an equivalent way to write tests that should fail and any operation within them returns an error variant. So it allows us to use the question mark operator in the body of tests. That's pretty cool. You can't use the should panic annotation on tests that use result. Instead, you should use the error value directly when the test should fail. Now that you know several ways of writing tests, let's look at what is happening when we run our tests and explore the different options we can use with cargo tests. Okay, first I do want to run this. Obviously it's going to pass, but I just want to see what, see that it works. It works. Very cool. So that's a cool other option for writing tests. That's pretty awesome. All right, moving on. Controlling how tests are run. All right, let's jump in here. Controlling how tests are run. Just as cargo run compiles your code, let me move out of your way again. Just as cargo run compiles your code and then runs the resulting binary, cargo test compiles your code in test mode and runs the resulting test binary. You can specify command line options to change the default behavior of cargo test. For example, the default behavior of the binary produced by cargo test is to run all the tests in parallel and capture output generated during test runs. That explains why our tests were not output in the order in which they occur in the file. They were run in parallel. And that's the default behavior. And capture the output generated during test runs, preventing the output from being displayed and making it easier to read the output related to the test results. So it collects them and prints it all out at the end. Running tests in parallel or consecutively. When you run multiple tests, by default, they run in parallel using threads. This means the test will finish running faster so you can get feedback quicker on whether or not your code is working. So that's awesome, right? Running parallel tests is much faster. Now, anyone that has experience with other languages, maybe you've, like we always talk about Java, Python, if you've ever written a server and you have some continuous integration running, you know that you want those tests to run fast, because when you need something to deploy, you want those tests to run, you want them to pass, and you want to get that code out there. Maybe you're deploying a fix for something. It's important that those things run fast, right? So parallelism is going to help with that because it runs it in threads. Because the tests are running at the same time, make sure your tests don't depend on each other or any shared state. That's key, including a shared environment, such as the current working directory or environment variables, right? They can't share stuff. If they're going to run in parallel, they should be units. They should be pure functions. They shouldn't have dependencies on one another. The output of one test should not be the input of another. For example, say each of your tests runs some code that creates a file on disk named test output text and writes some data to that file. Then each test reads the data in that file and asserts that the file contains a particular value, right? Which is different in each test. So one test might assert that it contains a string, one might assert it contains an integer. Because the tests run at the same time, one test might overwrite the file between when another test writes and reads the file. For example, test 1 takes the file and writes 1,000 lines and then asserts that the number of lines is 1,000. Well, since they're running in parallel, if test 2 starts in the middle and writes a single line to that file, right, it might interrupt because the other one was taking longer. There might be 1,001 lines. So you don't want to modify, or it might overwrite the lines altogether. So you don't want to run into that scenario. The second test will then fail because the code is incorrect, but because the tests have interfered with each other while running in parallel. One solution is to make sure each test writes to a different file. Another solution is to run the tests one at a time. It's going to be slower, but you do avoid that. I think the first option is probably what you want to do, right? Is use a different file. If you don't want to run tests in parallel, or if you want more fine-grained control over your number of threads used, you can send the test threads flag and the number of threads you want to use to the test binary. Take a look at the following example. We're running cargo test, and we set the number of test threads to 1, telling the program not to use any parallelism. Running the test using one thread will take longer than running them in parallel, but the tests won't interfere with each other if they share state. So, obviously, I would say parallelism is what you want. Avoid sharing state, right? Avoid it. But sometimes maybe you can't. So what we're going to do is we're going to run cargo test, and we're going to give it that test threads argument, and we're going to set that equal to 1. And I mean, for us, it was pretty fast, but that's because, well, what's going on here? I think we have an issue with what we passed. So let me see. I think we have an extra thing here we don't need. Let's see. Unused variable name. Finish tests, unoptimized debugging targets. So it's testing them. I also have to specify test threads. That's the problem. There we go. So it ran them. We can't tell that it's slower because we don't have many tests, but I take it. I understand. That should be, right? Because we are not threading there. Interesting. Showing function output. By default, if a test passes, Rust test library captures anything printed to standard output. For example, if we call println in a test and then test passes, we won't see the println output in the terminal. We see only the line that indicates that the test passed. If a test fails, we'll see whatever was printed to the standard output with the rest of the failure message. Awesome. As an example here in the below listing, here's a silly function that prints the value of its parameter and returns 10, as well as test that passes and a test that fails. So here we can run it. Look at that. All right, so here we have a function that prints the value of its parameter and returns 10, as well as a test that passes and a test that fails. So let's go ahead and copy this. We'll just paste it into our function here. We're getting a lot of functions in here now, but that's okay. Prints and returns 10, so it takes a value. I got the value blank, prints it, and returns 10. Very useless function, but nonetheless, it's going to illustrate what we're talking about here. So what I'm going to do is just copy these tests. This test will pass. This test will fail. And so now what we want to see is that it actually prints the output. So let's go ahead and run it. Let's get rid of that. All right. So here we can see our warnings. What are we expecting? I got the value. Let's see. When we run the test, we'll see the following output. Note that nowhere in the output do we see I got the value, so it doesn't actually print it, which is what is printed when the test pass which is what is printed when the test that passes runs. The output has been captured. The output from the test that failed, I got the value 8, appears in the section of the test summary output, which also shows the cause of the test failure. So it's going to show it in the failure case. So let's look there. This test will fail. Where is that test? Oh, you know what? We got to put here. What does this say? Never used. Fix that. Let's run this again. Where is it? Where is it? This test will fail. So let's see. Failed. This test will fail. This test will fail. Standard out. I got the value 8. So it printed it out in the failure case to give us a little more information. That's awesome. That's super awesome, because I know in JavaScript, sometimes when I'm dealing with stuff, I'm like, I don't see the output of the function and I don't know what was going on. And occasionally I'll throw a console log to see what's going on if I'm not using a debugger statement. Shout out to Lori, Clam Watson, if you're in the chat, you know what I'm talking about. Always left the debuggers in the code, classic. But sometimes you need a console log, right? So pretty cool. I like it. All right. Just so you have it, just so it's there. Just so you have it, exactly. All right, so that's pretty awesome. Running a subset of tests by, wait, is there anything where we can, okay, so here, let's get to this part. So we can use the show output flag to show the output of even our successful tests. So let's do that. Show output. I got value 8. Here's the successes. Look, I got the value 4. That's really awesome. So we can even show the output of the tests that pass. So pretty great. Running a subset of tests by name. Ooh, this is gonna show us how to skip stuff. Sometimes running a full test suite can take a long time. If you're working on code in a particular area, you might want to run only the tests pertaining to that code. Now, this is awesome because I often use this when I'm doing front end. So when I'm doing React applications, I'll use Jest, right? And I'll use a runner, a test runner. Like if I've used Create React App, right? And I'll run my tests in watch mode. And what I love is that I can run all the tests, or I can use a fuzzy search to say, hey, I just want to run tests that kind of match this, because let's say I have all of my test suite passing, but the function I'm working in has a few tests not passing. I can say, hey, just run the tests I know are not passing. Ignore the ones I know are good for now while I iterate on the code. And then, of course, run them all when you're done to make sure you didn't break something. But if you know that there's a particular thing you're trying to fix, this is a fantastic thing because it can make your iterations a lot quicker, right? And allow you to just focus on the tests that you're working on. You also might be working on the test itself, in which case it's much simpler to say, hey, I just want to work, I'm working on this test. And so it's pretty cool. All right, so let's check it out. Sometimes to run a full test suite can take a long time. If you're working on code in a particular area, you may want to only run the tests pertaining to that code. You can choose which tests run by passing cargo test the name or names of the tests you want to run as an argument. To demonstrate how to run a subset of tests, we'll create 3 tests in our add2 function. Okay, so we have our add2 function. Do we still have our add2 function? Did I get rid of that? Let's see. All right, still got it. Such a good function. Yeah, look at this function. Like, this is why I learned Rust, right? Like, I didn't know. I was trying to add 2 to a number, and it's hard to do, and Rust just makes it so nice, right? What a powerful function this is. All right, so let's add 2 more cases. So let's go down to our tests here. And I'm just going to copy them because there's nothing new here that I want to type. All right, so we have 2 and 2 is 4. We got 3 and 2 is 5. 102 should be 102. All right. If we run these tests without passing the arguments, as we saw earlier, all the tests will run in parallel. Let's do that just to illustrate what the output looks like so that we can see it. So I'm just going to go ahead and run that there. And you can see all our tests ran. Here are the ones that are successes. Here are the ones that are failures. So just to illustrate that they are all in fact running. Okay. We can pass the name of any test function to cargo tests to run only that test. So let's go ahead and pass what they have here, pass the name 100. So here we're going to just clear this out. I'm going to run cargo test 100. And there, it only ran that single test. It finished testing it, printed out our warnings, no big deal. And there we have it. So pretty awesome. Only the test with the name 100 ran. The other 2 tests didn't match that name. Test output let us know we had more tests than what this command is displaying. And how did it do that? Check this out. 11 filtered out. So it said, hey, we ran 1 test, right? Actually, in this case, it ran 0 tests. So we didn't get our name right because I didn't save. See, 0 passed, 0 failed, 0 ignored. So let's try that again now that I've saved. There you go. 1 passed, 0 failed, 0 ignored, 13 filtered out. So it's indicating to us, hey, you haven't run your full suite. So that's pretty awesome. We can specify the names of multiple tests in this way. Only the first value given a cargo test will be used, but there's a way to run multiple tests. Filtering to run multiple tests. We can specify part of a test name, and any test whose name matches that value will be run. For example, because 2 of our test names contain add, we can run those 2 by running cargo test add. Yo, this is what I'm talking about. This is like the fuzzy thing I use on the front end. Come on, this is great. All right, so what does that mean? We're going to run cargo test add. It's going to run any test that contains add. So that'll help us organize our tests so that we can do stuff like this, right? Cargo test add. So here we have 3 passed, 0 failed, 0 ignored, 0 measured, and 11 filtered out. So it actually ran these 3. Add, add, and add. Pretty awesome. Pretty awesome. I like that a lot. Ignoring some tests unless specifically requested. Sometimes a few specific tests can be very time consuming to execute. for sure. So you might want to execute them during the most runs of cargo test. Rather than listing them as arguments, all tests, so hold on. Sometimes a few specific tests will be very time consuming, so you might want to exclude them during most runs. So exclude them during most runs. Rather than listing as arguments all tests you do want to run, you can instead annotate the time consuming tests with ignore. So it's actually excluding instead of including. You can put them with ignore, and that'll ignore the test. So that's pretty cool. And we should see that in the ignored. So I'm not going to do that because I'm just going to assume that that's the case. Actually, we can do it for this one. We have it adds to. We can ignore this one. Let's ignore it. All right. Now let's run it and just see that that output is the case here. So we're going to run clear cargo test. And one ignored. Pretty cool. So yeah, that's definitely a good feature to have, especially like they've illustrated here with a long test or something that is going to take a while. Absolutely good to be able to ignore that. And it still tells you that it's ignored, so you're not, you need to actually run that at some point. The expensive test function is listed as ignored. If we want to run only ignored tests, we can run cargo test ignored. That's pretty cool too. By controlling which tests run, you can make sure your cargo test results will be fast. When you're at a point where it makes sense to check the results of the ignored tests and you have time to wait for the results, you can run cargo test ignore instead. Very cool. Test organization. Look at this. Ooh, we're doing pretty good. We're breezing through. I think we'll be able to finish this up really nicely. I'm excited. What time are we at? We're doing good on time, right, chat? Yeah, 10:22. We're doing great. All right. Test organization. If you know me, you know I love organization. Clearly, by the mess that is my room. Now, I'm not good with organization, but we're going to get there, right? Recondo. As mentioned at the start of this chapter, testing is a complex discipline, absolutely. Full agree. And different people use different terminology and organization. The Rust community thinks about tests in terms of two main categories: unit tests and integration tests. Unit tests, integration tests, right? Unit tests are small and more focused testing one module in isolation at a time. That's what we've been writing. We've been writing unit tests and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way that external code would consume and use your code, using only the public interface and potentially exercising multiple modules per test. So the reason you have public code is because you want to expose functionality. The reason you have private code is that code is called at some point by your public code, otherwise it would be useless to have in there. So an integration test calls your code from the public code, whereas a unit test calls the internal private functions. Clam Watson, oh, you think mess is your ally, but you merely adopted the mess. I was born in it. You think mess is your ally. You merely adopted the mess. I was born in it, molded by it. Yeah, it's getting pretty organized in here. I got some good organization. I just gotta get some stuff off the bookshelf, but we're doing pretty good. This side of the room's looking good. Chat, you've never seen this side of the room. Now you can see it. We got a little table going on. We're getting a color theme going on. I'm working on it. But we don't use that view much on stream, but we will. We'll get there. We'll get there, chat. You think you're in charge. Okay, so unit tests. Internal code, private code, small units. It's what we've been writing. Integration tests. External code to your library, public code, right? The purpose of unit tests is to test each unit of code in isolation from the rest of the code to quickly pinpoint where code is and isn't working as expected, right? You'll put unit tests in the source directory in each file with the code that they're testing. The convention is to create a module named tests in each file to contain the test functions and to annotate the module with config test. Now, this is telling us where to put it. It's telling us a convention. If you're from other languages or you've tried JavaScript, you've tried Python, you've tried Java, you've tried Haskell, you've tried Elixir, not every language has conventions like this, which gives you a little more freedom. But that said, And I'm sure anyone out there that has experience jumping from code base to code base, it is very difficult to navigate a new project that does not have conventions like this. So the fact that Rust is kind of agreed on and the community is kind of settled and distilled on a set way of doing things, it's going to make it really easy for folks to navigate a code base because you know where the tests go. And it makes it one less decision we have to make as developers, right? This may change. We may find a better place for it. But for now, it's nice to have a preferred way. And some people call this a best practice. You could call this a style guide. But in this case, it's just kind of built in as a convention. So pretty cool. Okay. The test module and config test. The config test annotation on the test module, which you can see here. See that here? Tells Rust to compile and run the test code only when you run cargo test, not when you run cargo build. This saves compile time when you only want to build the library and saves space in the resulting compiled artifact because the tests are not included. We don't want to ship our tests with our bundled library because it'll add to the bundle size. You'll see that because integration, I'm sorry, I said bundle JavaScript. I mean binary size. You'll see that because integration tests go in a different directory, they don't need the config test annotation. However, because unit tests go in the same file as your code, you'll use config test to specify that they shouldn't be included in the compiled result. So it's because it's alongside our code, right? Recall that when we generated the new adder project in the first section of the chapter, Cargo generated the code for us. And it generated this little bit here, config test with the test thing. This code is automatically generated test module. The attribute config, CFG stands for configuration, and tells Rust that the following item should only be included given a certain configuration option. In this case, the test option. Cargo test, which is provided by Rust for compiling and running tests. By using the CFG attribute, Cargo compiles our test code only if we actively run the tests with cargo test. This includes any helper functions that might be within this module, in addition to the functions annotated with #test. Yeah, just click on the chat, friends, and have a directory where you commit all your debuggers. Testing private functions. Ooh, I like the way this chapter is starting out with a little spice. There's debate within the testing. I like when anytime they're like, there's been a rift in the testing community. There's debate in the testing community about whether or not private functions should be tested directly. And other languages make it difficult or impossible to test private functions. Whoa. Impossible. Regardless of which testing ideology you adhere to, Rust privacy rules do allow you to test private functions. So they're basically like, well, yeah, whatever we're going to allow it. Well, you do you. We're going to allow it. And let's check it out. Consider the code with the private function internal adder. So let's go ahead and make that. So again, we didn't have to make these public explicitly because we used super, we pulled them in, it's in the same file. But, if we were using this somewhere else, we would have to. But so what we're going to do is we're going to be a little explicit about it. And you can see, actually, it's letting us test it as a private function. We didn't have to make them public. So we don't need this. We see that this works. It works here. Pretty cool. We did it already. So that's awesome. So it lets you test it. Why does it let you test it? Because that's how we write unit tests. We want to be able to test private functions, right? In Rust, integration tests are entirely external to your library. They use your library in the same way other code would, which means they can only call functions that are part of your library's public API. So this is key. An integration test is going to use the public-facing surface of your API, what people would use, what they would consume, right? And the intent is that those public functions that somewhere along the line call your private functions and call other functions, because otherwise you wouldn't have those functions, as I mentioned. And so this is going to count as an integration test. The purpose is to test whether many parts of your library work together correctly. Units of code that work correctly on their own could have problems when integrated. So test coverage of the integrated code is important as well. So imagine, to give an example, if anyone's not familiar with this, Imagine our add2 function, right? Our add2 function adds 2 to a number and returns an integer. If we write a test that asserts that it adds 2 to a number and we do 2 plus 2 is 4, that unit works. But what if we had a function called return 10? And return 10's test it's supposed to just return 10. And so at some point it calls your add2 function and adds the 4 that it gets from 2 to a number, and it assumes that that's 10. Well, depending on what your code does or if it changes, that integration could break if your code all of a sudden returns a different number. Maybe you update your unit test, you update your code to add 3, and now that other test fails. So even though the unit itself could work, when it's integrated, it could fail. Maybe you change the return type. So you update your test so that it returns a string. You update your code to return a string. Well, now the code calling your code might fail. Of course, the compiler would catch that case, but just an example. We create a test directory. So first we need to create a test directory. Okay. We create a test directory at the top level of our project directory. All right, so let's do that. So here's our project directory. I'm going to create a, actually it's got to be inside. Okay, I see. It contains it. We're inside that folder. Okay, so let's do this. Let's do tests, and let's move tests to adder. Okay, so we have a test directory. Let's create an integration test. So we're going to create another file called integration test.rust. Okay, and we're going to pull in use adder. And so that's here. I'm going to create make sure my add2 function is public. Okay, it is. All right. And, oh, actually, sorry, we wanted this at the, what level? Top level of our project directory next to source. Yeah, so we did good. Okay, we did it right. So we're going to use adder, and then we're going to write the test function. It adds 2, and we're going to assert equal, and just the same assertion we were doing before, 4. And then adder, and the reason we're calling it adder is because the folder is called adder, so that's the name of our project, and by default the librs gets the name of the project. So remember, it's kind of like an index.js in JavaScript, but it's a library binary, so that's how we're going to be able to use that. And so we're going to call adder add2 2, and let's just make sure that that's the name of our function. Yep, there it is. So we save that. We've added use adder to the top of our code, which we didn't need in our unit test because we were in the same file. The reason is that each file and test directory is a separate crate. So we need to bring our library into each test crate's scope. We don't need to annotate any code in integration test with config test. Cargo treats the test directory specially and compiles files in the directory only when we run cargo test. So because it's in a directory name test, it knows not to include it. We don't need that config test explicitly. So let's go ahead and run cargo test and see what happens. So in here we have our successes, and we have it adds 2, but let me see if we can figure out. Let's see. So we should have some from our integration test file here. We have 14 tests, running target, adder, I don't know if it ran this one. Let's see what it says here. The 3 sections of output include unit test, integration test, and doc test. Do they? let's see. Running 14 tests. Okay. So running one test internal. So we only had one case run here, so it didn't run our test. Let's see why it didn't run it. So first we save that. We're in the test folder. Let's see. I'm just going to clear this out and run it again. So we have 10 passed, 3 failed, 1 ignored. I don't see. Let me get rid of the it adds to from here. So I'm just going to go to my lib. It adds. Oh, I guess it did run it because I don't have that. I don't have that test here. Oh no, I do. So it doesn't. Oh, here we have test another test screen. I don't see it. Patatas said a Rust quiz. Can you try to answer this one? Yeah, maybe we'll try if we have time at the end of this. So this test failed. Oh, maybe because it failed, it didn't continue them, which is probably actually pretty likely. So let's do this. Let's go ahead and clean up lib real quick, or at least ignore those. So another we can get rid of. We can get rid of the test called another. We don't need this. What other one failed? Contains name. Just ignore that. And the other one was this test will fail. Wait, so we have this test will fail. Another greeting contains name. All right, I think we're good. I'm going to clear this and run cargo test again. Where is this test will fail coming from? Why can't I search this file? Let's see, smaller. It adds 2. It works. This test will fail. Why is that not showing up in my search? Interesting. Okay, let's try it now. Cool, there we go. So my unit test passed, and then it ran my integration test, and you can see it here. And then it tried to run doc test, but we don't have any. So awesome. So because the other ones failed, it didn't even go on to the integration tests, which is awesome. So it makes you pass the unit test, then it runs the integration tests. And there we see our integration test. It starts with the line running. It shows you the file, right? The hash to the end of the output will be different because it's obviously a built file. Next, there's a line for each test function in the integration test and a summary of the line for the results of the integration test just before the doc test adder starts. Similarly to how adding more unit test function adds more result lines to the unit tests, adding more test functions to the integration file adds more result lines to the integration tests file section. Each integration test file has its own section. So if you add more files to that, we'll get their own section. That's pretty cool. We can still run a particular integration test function by specifying the test function's name as an argument to cargo test. To run all tests in a particular integration test file, use the test argument of cargo test. So here we have this one. So let's try that out. So let me zoom in a little bit so it's a little bigger. And then I'll get rid of that. All right, let's move this to the side here. I'm just going to clear this, run cargo test, but I'm going to include the test. And I'm going to say integration test. Cool. And it just ran that. That's pretty great. Awesome. Submodules and integration tests. As you add more integration tests, you might want to make more than one file in the test directory to help organize them. For example, you can group the test functions by the functionality that they're actually testing. As mentioned earlier, each file in the test directory is compiled as its own separate crate. So that's pretty cool. Treating each integration test file as its own crate is useful to create separate scopes that are more like the way end users will be using your crate. However, this means files in the test directory don't share the same behavior as files in the source directory do, as we learned in Chapter 7 regarding how to separate code in modules and files. The different behavior of files in the test directory is most noticeable when you have a set of helper functions that would be useful in multiple integration test files, and you try to follow the steps in separating modules into different files, section of Chapter 7, to extract them into a common module. For example, if we create tests common and place a function named setup in it, we can add some code to setup that we want to call from multiple test functions in multiple test files. So that's good. We can reuse code to set up multiple different tests. When we run tests again, we'll see a new section in the test output for the common RS file, even though this file doesn't contain any test functions, nor do we call the setup function from anywhere. Having common code appear in the test results with running 0 test displayed for it is not what we wanted. We just wanted to share some code. We didn't want it to be counted in that output, right? To avoid having common appear in the test output, instead of creating tests common RS, we'll create tests common mod RS. This is an alternate naming convention that Rust also understands. Naming the file this way tells Rust not to treat the common module as an integration test file. When we move the setup function code into tests common mod, so we move it into a common folder, and delete the test common file, this section in the test output will no longer appear. Oh, that's pretty cool. So files and subdirectories of the test directory don't get compiled as separate crates or have sections in the test output. So we could put it in its own, oh, I like that. You could put it in its own little structure there. That's pretty great. After we've created test common mod, we can use it from any integration test file as a module. Here's an example of calling the setup function from the it adds two tests in integration. So let's do that. I want to, just so we have that as an example. So I'm going to go ahead and in my test folder, I'm going to create a new folder called common. And in there, I'm going to create a new file called mod.rs. And we'll just put that, fake boilerplate code that they had there, which is just setup. And it's not going to do anything, but we'll just create a public function, pub function setup, just to illustrate it. Very cool. All right, so there we go. And then back over here in our integration tests, we can pull that code in. And so the way we do that is here we're going to do mod common, and then we can call our setup function. Oh. All right. Common setup. Note that the mod common declaration is the same as the module declaration we demonstrated in listing 722. Then in the test function, we can call common setup function. Awesome. Integration tests for binary crates. So binary crates, again, are the not the library ones. They're the ones with the main RS, ones we generally create, which, for example, we're like here, we have like a project. That's like what we call a binary crate. So if our project is a binary crate that only contains a main RS file and doesn't have a lib, we can't create integration tests in the tests directory and bring functions defined in the main file into scope with a use statement. Only library crates expose functions that other crates can use. Binary crates are meant to be run on their own. This is one of the reasons Rust projects that provide a binary have a straightforward source main file that calls logic that lives in the lib file. Using that structure, integration tests can test the library crate with use to make the important functionality available. If the important functionality works, the small amount of code in the main file will still work as well, and a small amount of code doesn't need to be tested. What that's saying is, if you are writing code that you want to test, you would extract it from the main function into a library that you can then put under test. And you leave the main function as small as possible so that you don't need to write tests against it, and you put the bulk of your logic into the library. So, summary. We did it. We learned about testing. Rust testing features provide a way to specify how code should function to ensure it continues to work as you expect. Even as you make changes, unit tests exercise different parts of a library separately and can test private implementation details. Integration tests check that many parts of the library work together correctly, and they use the library's public API to test the code in the same way external code would use it. Even though Rust type system and ownership rules help prevent some kind of bugs, tests are still important to reduce logic bugs and make sure your code does what it says it's going to do. Let's combine the knowledge you learned in this chapter and previous chapters to work on a project. All right, so what does that mean? Next chapter, we're not going to start today, but next week is the 23rd, so we're getting a little close to the holidays. So we'll see if we're going to change the date on that or postpone it, but as of now, it's still planned for for next Tuesday. We will be jumping into chapter 12, which is going to do exactly what we wanted to do, leverage what we've learned to build a command line program. So we're going to use all of our knowledge that we've built up on to build out a command line program. And also, the cool thing about that is it'll be a fun project. It'll be like a good use case. We can actually put our skills to use, and kind of like what we did at Rustlings, but like an actual full-out project with module structure, folder structure. And I want to check out, so Patatas in the chat sent out a quiz. I want to check it out. We'll see if, I don't know if we're going to get to it today, but if not, we can do it first thing next stream. Let me just paste it in here. Yeah, so I'm excited about chapter 12. Chapter 12 is going to be pretty sick. I've been wanting to like build a project with the stuff that we've learned. But who knows? All right, check this out. Patatas. Thank you, Patatas. Patatas is always showing up, killing it in the chat with some tips. What is this? This is pretty cool. There's like little Rust quizzes. Can you, Patatas, I'm going to put a note to this in the show notes. This is really cool. So it's a little quiz. Let's check it out. What is the output of this Rust program? Let's see if we can figure it out, chat. Patatas, don't give the answer if you know it. If you don't know the answer and you actually are genuinely guessing, spit out a guess. Okay. Function check. Check takes a signed 32-bit integer and returns a bool. It first prints, well, is there a print macro? Where's ln? I guess it prints without a new line, right? And then it returns false. Main, match 1, 2. So it's a match expression on this tuple. Okay, so it's a match expression on this tuple. Can you give a quick check out my theme update before ending? Yes, Greyjack, I will check out your theme. We'll do the quiz and then we'll check it out. All right. I wonder if it updates. It probably updates on its own, but let's see. So let's see what we got here. So match, it's a match on this tuple 1, 2. And it's saying if it's this case, if it's X or something or X, if check X. So this or this if check X. So X is going to be false. False or false. Oh, okay. This is confusing. Okay, so our match expressions on this tuple, we're using an if statement here. This or this if check X. So not this, right? Because check X is always going to return false regardless of what X is. So if we assume it's this. Oh, this is interesting. Otherwise, just print 4. So if it doesn't match either of these, just print 4. Okay. There's a hint button. I don't want to hit the hint button yet. I want to walk through one more time and then I'll try the hint button. So check. All it does, takes the signed 32-bit integer, returns a bool, and first prints it, right? So it's going to print it. So what is this bit doing is what I want to know. It's like X, or it's a union type or something. It's like a union match. It's like X. It matches this, right? So it does match this. So it should do this first. It shouldn't even use this code, right? It shouldn't even go here. All right, let's use the hint. Either way would be confusing in different situations. There isn't a clear right behavior that a hint could help identify. Guess both. Okay. So I'm going to guess that it prints out Oh, okay, okay. Is this like both cases? I see. In both of these cases, do this. But this is false. Okay, but it's going to call this regardless. Okay, okay. I'm going to take a guess. I'm going to guess that it prints out... I'm going to guess that it prints out 1, 2, 3, and there's no breaks. So I'm going to say it prints it out at all. Incorrect. Damn it. Does it not print out 4? Whew. So what I'm thinking is it's going to hit this case, right? So it matches this. So it's going to print 3. It also matches. It doesn't match this because this is false. Oh, maybe it's 3. Oh man, I don't know. Either way would be confusing in different situations. There isn't a clear right behavior that a hint could help identify. Guess both. Okay, so I feel like it's gonna print out 2, 3, 4. I'm just guessing at this point. I don't know. I'm gonna have to reveal it. I want to know. The question covers 2 behaviors of match arms and guards. First, whether an if guard on a match arm containing the pipe applies to all alternatives in the match arm or just to the one adjacent to it. In the quiz code, does check X execute at all for X for this one? Yeah, that's like that was what I was tough. Or does it only cover the second case? We would expect 1 would get printed if and only if the former is the case, right? Because if the former is the case, then check X would print it, right? If it works on both. In fact, 1 does get printed. A match arm gets to have at most 1 if guard, and that guard applies to all. Okay, so that's huge. That's awesome. But second, the question also covers the kind of backtracking behavior of the match arms. After check X returns false, does the whole match arm fail to match at that point, or does Rust move on to the _X, execute the guard a second time? We'd expect 2 to be printed out if and only if the latter is the case. In fact, 2 does get printed. The guard is being run multiple times, once per. Wow, that's a cool one. That's super interesting. That's like some funky stuff. Hopefully you never write code like this, but that's awesome. All right, Great Jack, as promised, I wanted to try out your theme. Let me go to my color theme. Monokai Gray Jack. I like the pastel one. Ooh, it looks great. I want to see the other one too. Where is it? Why doesn't it show up when I search gray? Oh, I'm spelling gray wrong. Ooh, both look nice. Patatas, yeah, thanks for that quiz. That was awesome. So Gray Jack, here is the new theme. I like it. It looks awesome. The syntax highlighting is really nice. One thing I'm noticing right away is the syntax highlighting and stuff like this is pretty great. The ignore has nice highlighting to it. Awesome job. Although this, it looks like this old version. Although, so it is, even though it might be the old one, it's better for me than the first time because I have Rust Analyzer. Let's see if we can update it. And I didn't have Rust Analyzer before, so it does look good. But let's see. Gray Jack. Reload it. Ooh. Wait, is this your release notes? No, that's for material theme. Ooh, is this it? Language server, let's get that. Let's go to one of our Rust analyzed here. Ooh. Oh yeah. Colors look good. Let's try the pastel one. Color theme. Ooh, nice. Yeah, this looks great. I really like it. Did you change the side here? I don't remember looking at this. This looks nice. Awesome job. It looks a lot. It looks similar to Monokai Ocean, which I was using. So Greyjack in chat said the code colors had some improvements as well. Yeah, they're definitely not as like glaring. The reds are nice. It's awesome. Cool. Yeah, I'm definitely down to try this out. It's very similar to what I have, but I think it has better highlighting for Rust, which is really cool. Like self wasn't highlighted before. Now it is. This is awesome. Nice job. All right. I think that's where we're going to end it. Ooh, I'm looking at it on stream. It looks great on stream. So I think we'll have to try this one out. Thanks, Greyjack. All right, everybody. So that is where we're going to end it for tonight. We are just about at 11 p.m. We finished chapter 11. We had a little quiz from Patatas. We tried out Greyjack's theme. It's been an overall successful night, I think. And next week, we're going to be building the IO project, command line program. Also, Greyjack, I will put a link to the theme in the show notes. I don't remember if I forgot to do it last time, but I will do it this time. So thank you for that. All right, so next time we're going to be building an IO project. I'm excited. We'll probably have to just start it. I don't know if we'll be able to finish it in one session, but we'll just keep going with it. We are making our way through the book. This has been a lot of fun. I'm enjoying it. Again, for those of you joining late or joining on YouTube who haven't checked it out, all the past videos will be posted here. You can see them all. We got the Rust. We got the serverless app. We got the Rustlings exercises. This video will be posted tomorrow, so I always post it the following day. So expect that. If you're watching on YouTube, thank you so much. I really appreciate it. We've been getting a lot of great comments, awesome amounts of views, so really enjoying that. Feel free to subscribe and like the video, and you'll get notified when we post more. It's always really appreciated. If you're watching on Twitch and you've participated in the chat like Greyjack did, Patatas, we had Clam Watson, thank you. It's been a lot of fun. It's always great to have the live chat because we can work on stuff together. Today we had an awesome quiz from Patatas. We got to try out an awesome theme from Greyjack. Clam Watson's always been a regular in here, so that's awesome. And a few others popping in and out. So anyone that's stopping by, I appreciate it. If you do want to check out the stream, if you're watching on YouTube and you want to check it out live on Twitch and get involved in the chat, Tuesdays, 9 p.m. Eastern Time to 11 p.m. every Tuesday. You can follow me on Twitter. You'll get notified for when I go live. And I'll also occasionally post when I put videos up on YouTube as well. All the code we're going to be doing here is going to be pushed to my GitHub repo. So check it out there. And that's it for tonight. Next week's going to be crazy. I'll keep you all posted. I'm not sure what the holiday schedule is going to look like. I want to, take a break from maybe for a week to do some holiday stuff. But we're going to see how the Tuesday, I think Tuesday is going to be, we'll see. Obviously, I'll post on Twitter. I'll keep everyone up to date onto when I go live. I'm also going to be potentially, I've been talking about it, adding another day. I think we will start doing that as of next year. More to come on what day that is and what time and everything like that. Thank you again for stopping by. Thank you for watching on YouTube. If you're watching on YouTube, I really appreciate it. Hope you've been enjoying learning Rust. And we're going to get started. We're going to dive into chapter 12. 11 was a lot of fun. We learned how to test. More to come. Only great stuff. We're becoming Rust stations. We really are. And I love it. Everybody have a good night. I'll catch you soon. Later.